Hello students, this is the second video in the lecture series on perspective views. In the first lecture, we have discussed about the basic concepts and the terminology that we use in perspective views. Now in this video, we will learn how to make one-point perspective view of a given object. So let us start. So the first video in this direction is on one point perspective drawing. So in such problems the data may be given as given in this case. So we are given the orthographic drawing of an object in which you are given the front, top and the right hand side view. The other details that are given to draw the perspective projections include that the station point is 150 mm away from the picture plane and it is 60 mm towards the right side of the rightmost edge in the top view. Also the height of the eye level of the observer in this case is given to be 90 mm above ground line. So the important things to be noted when we are going to start this problem from the given data include that first of all we need to draw the one point perspective. So it means in this case there will be only one vanishing point. Secondly, since in this case the height of the eye level of the observer is 90 mm above the ground line, the ground plane, so it means we are going to get the bird's view in this case. From the three given views of the object, we can easily make out that the given object is nothing but a simple cube with an edge length of 50 mm. Whenever we are solving any problem on the perspective drawing, we always need to keep this picture in mind. This picture shows the various elements that are required in making the perspective view or drawing of an object, and this was also discussed in the previous video, the meaning of all these terms that are being used in this picture. You always need to keep this picture in your mind for understanding the concept of perspective drawings. So the given object is a cube in this case, and the different faces which are visible from the front, top and side are distinguished by three different colors. So the front is available as yellow face, the top is available as a green face, and the right hand side view was given to be blue. For the sake of understanding of this problem, let us put the name of the vertices of the cube. The ABCD makes the top face of the cube, whereas 1, 2, 3, 4 makes the bottom face of the cube. Now we need to understand that when we are making the one point perspective of an object, how do we place this object into this reference frame? In making the one point perspective view of this given object, the first thing we need to do is we need to just place this object on a ground plane. So let us place this object on a ground plane. So we assume that the object is placed on a ground plane. Ground plane is an infinite sized plane, and the given object, that is cube, is completely resting on it. The next element to be introduced in the concept of perspective drawing is the picture plane. The picture plane is an infinite sized vertical plane. Whenever we are making the one point perspective view of an object, we need to ensure that the face of the object which is available to us in the front view must be touching this picture plane completely. That is to say that the face of this cube which was available to us in the front view, that was a yellow colored face, must be touching this picture plane completely. So this is how the object will be placed. You can see in this case the face AD41, the yellow colored face, is completely touching the picture plane while the object is resting on the ground plane. Now, after placing the object, the next step is that we need to locate the given observer. In the statement of the problem, the data regarding the location of the observer is given to be that it is 150 mm from the picture plane and it is 60 mm on the right of the rightmost edge of the object. So from the given data we can make out that the observer in this case is standing like this. This green line represents the observer. So the height of the eye level is also given to be 90 mm above the ground level. So this red spot here represents the eye level of the observer, and the feet of the observer are shown here, and this point is also known as station point. So the station point is 150 mm from the picture plane and it is 60 mm on the right of the rightmost face of the object, and from the station point the eye level is 90 mm. There's yet another important observation in the given data, that is regarding the eye level. The eye level is given to be 90 mm, whereas the maximum height of the object is 50 mm, since it is a cube of edge length 50. So in this case we can make out from this information that since the eye level is higher, so the observer will definitely get to see the top surface of the object. So in this case we should expect the bird's view. So as per the given data in the statement, we have placed the given object on the ground plane. We have placed the object in such a way that one of its face is touching the picture plane, since we are going to make the one point perspective view. And then we have also located the observer, in this case the eye of the observer, as per the given data. So all this activity needs to be done keeping this concept in mind. Now at this stage let us introduce another idea. If you are an observer to this entire scene here and you are situated at this location, so this is your position here, so how will you see this complete scene from this position, that is in top view? What will you get to see from this given scene if you are placed here? So from this position the picture plane will look like a line, and for this object you will be able to see the top face, the green colored face, and as far as this observer is concerned, you will be able to see this observer as a point. So if you are placed here, then you will be able to see picture plane as a line. You will see the top view of the given object, the green colored face, and you will be able to see this observer as a point as per these given distances here. So this complete scene will be available to the observer at this location like this. So this red line here indicates the picture plane. The object is viewed here as face ABCD, which is a green colored face. The observer is here at the station point, which is 150 mm from the picture plane and it is 60 mm on the right side. So that is the location of the observer as viewed from top, that is this place. So this is the top view available to the observer sitting here. In yet another scenario, if you are standing at this location, then how will you look at this scene from this location? That is, if your position is represented by this red spot here, how will you look at the different elements from this location? This ground plane will look like a horizontal line to you from this location. Now if you refer to this figure, then there is another horizontal plane in this case, which is passing through the eye level of the observer. So if I put another plane which is called as horizontal plane, and this plane is passing through the eye level of the observer, so these two planes, that is the horizontal plane and the ground plane, will look like two horizontal lines separated by a distance of 90 mm from this location to you. As far as the object is concerned, the object will look like a yellow square face, that is AD41, from this location. So from this location you will be able to see the horizontal line representing the ground plane, another horizontal line separated by a gap of 90 mm. That horizontal line will represent the horizontal plane, and the object itself will look like face AD41. So it can be summed up that view from this location will be looking like this. So this line is the ground line, the ground plane line. This line represents the horizontal plane. The two lines are separated by a distance of 90 mm. This is the observer, and this is the face of the object AD41, the yellow colored face. So these two views from the top and the front can be vertically aligned and placed like this. So this is the view from the top and this is the view from the front. So in the top view it is picture plane, the top face, the location of the observer, the station point, and this is what you see from the front, the ground line, the horizon line representing the horizontal plane, and the front face of the object, that is AD41. These two are separated by a distance of 90 mm. Now these two views need to be vertically aligned, that is point D in the top view and the same point D in the front view. They should be vertically aligned as we have been doing in case of orthographic projections. So this is the start point of the 1-point perspective drawing. So this is all about the concept, how these two views are made. This whole story is all about the concepts, how do you reach at this stage. Now beyond this there is some procedure that needs to be followed. Another important point to be noted, unlike the orthographic projections, in this case the top view is placed on top and the front view is placed below the top view. Now the entire discussion we had so far is all about the concept, how to reach at these two views, the top view and the front view. Now beyond this there is a procedure to get the 1-point perspective view of the given object. Now the next step is to identify the vanishing point in this case. Since we are making the 1-point perspective, so there will be only one vanishing point in this case. The property of the vanishing point is that it always lies on the horizon line, that is the horizontal plane, this line. So you will always find the vanishing point on this line. Now in this case the vanishing point on this line can be simply located by dropping a vertical line from the station point onto this line. So if I simply draw a vertical line from the station point onto this point here will become my vanishing point in this case. However, in case of the 2-point perspective, the next topic, the vanishing points will definitely lie on this line, but the procedure to get those points will be slightly different. But in case of 1-point perspective, you simply draw a vertical line from the station point onto this horizontal line. This point here is the vanishing point itself. So the vanishing point is right here. It can be marked as VP here. After identification of the vanishing point, the next step is to connect all the vertices of this face in the front view, that is vertex A, D, 4 and 1. All these vertices need to be connected to the vanishing point. that is like this. So we connect AD41 with the vanishing point. Now consider this concept in mind. The face AD41, the yellow colored face, is already touching the picture plane. So this face has to come in the perspective as its true shape. All the points which are not lying on the picture plane, that is vertex B, C, 3 and 2, all those vertices and all the edges passing through these vertices which are not lying on the picture plane, they need to undergo some kind of reduction in size. Now we can understand from this concept that point B, for example, does not lie on the picture plane. Now where does point B lie actually? Point B lies on the edge which is passing through point A, and it is going in this direction. Now if I compare the isometric view of this object, so I need to locate point B, this point B, in this perspective drawing here. So point B lies on this edge, passing through, starting from point A, going in this direction. So B lies on this. Now in case of perspective, the B should lie on the same edge. It should lie on this edge which passes through point A, and it ends at vanishing point. But where does point B lie on this? That needs to be ascertained. Now to ascertain that, what I need to do is I'll draw a line from the station point here, and I will connect this line in the top view with this point, that is B. So I connect point B with the station point in the top view. Now this line actually represents the line of sight. That is, if the observer is like this, if the observer is here in 3D, the observer is here, this is the eye. How does the eye of the observer see this point B here? So this line is actually the direction of sight of the observer for point B. Similarly, you can draw another line for point C, which does not lie on the picture plane. So this line here represents the direction of sight for point C. So all such points which do not lie on the picture plane, like B, C, 3 and 2, all those points need to be connected to the station point in the top view, like this. And then this line, for example for point B, this line actually meets the picture plane at this location. So this location here, this location, this point here is called as the piercing point. This is the point at which the direction of sight of the observer actually pierces through the picture plane. So this point here, the line connecting B in top view with the station point, wherever this line meets the picture plane line, that point of intersection here is called as the piercing point. Now from this point, from this piercing point, you need to draw a vertical line until this line, the line which is connecting A with the vanishing point. This line here needs to be connected up to this line here. So this point here is actually point B. So you need to draw a vertical line from the piercing point and drop it onto this line, which is line connecting A with the vanishing point. So this is the line on which we are expecting point B to lie. So to identify point B on this line, you need to first find the piercing point for B. The piercing point of B can be obtained by connecting station point and the top view of point B. So this is the piercing point for B. From this piercing point, you drop a vertical line and take it to this line which connects A with the vanishing point. So this point here is the point B in perspective. So this is point B in the perspective here. Now I can repeat the same process for the other points which do not lie on the picture plane. For example, just below point B lies point 2. So for 2, if I need to find the piercing point, I will just connect 2 with the station point, that is the same line. I will get the same point as the piercing point for point number 2. Then I will drop a vertical line from this piercing point until that line on which I am expecting point number 2 to lie. So if I just look at this isometric here, point number 2 is lying on this edge which is starting from 1 going in this direction. In case of perspective, point 2 is expected to lie on this line which starts from 1 and it ends at the vanishing point. So this is the piercing point for point number 2. I drop a vertical line. So if I just extend this line and I take it further down up to this location, so this was point B here on this line passing from A to VP, and the same vertical line extended downward should give me this point 2 here, because 2 is expected to lie on this line. So 1 leading to vanishing point, this is the expected point 2 here. So this way I can get the point number 2. So that is point number 2. Same procedure can be adopted for getting any point that does not lie on the picture plane here in top view. For example, same process can be applied for point C also. Connect point C in top view with the station point. Wherever it meets the picture plane, that is this red line here, so that point is the piercing point for point number C, and then from this piercing point we can draw a vertical line until this edge on which I expect point C to lie. So point C is expected to lie on the edge which is passing through point D and going up to vanishing point, that is this edge. So point C is expected to lie on this line and it has to be vertical one. So that's the point number C in the perspective. So this is point C here. That's point number C here. So now we can just connect all these points, that is A, B, C, D, and on this side we can connect A, B, 2 and 1. So this will make the perspective 1 point perspective of the given cube. So connecting point D with C and then with B and then with A, and same way for making this face AB 2 and 1. So that makes the perspective of that particular cube, and if you wish to make it colored faces also, then you can use this fill command. So that is the top face and this one is the side face. Now you can compare the isometric and perspective of an object. In this case you can see the face AD41 is also appearing here in its true shape, that is AD41, because this is the face that is completely touching the picture plane. So anything that lies on the picture plane appears in its true shape, whereas all the edges or the vertices which do not lie on the picture plane, like in this case B, C, 2, 3, and all the edges passing through these vertices, they appear to be reduced in size. For example, in this case, if you look at this carefully, uh, edge A1 is the true length, that is 50 mm, because the cube edge length is 50. So 1A is 50, AD is 50. But if you look at the corresponding edges at the rear face, that is B2 and BC, they appear to be somewhat reduced in size. So that is the feature of the perspective views, that it adds an element of realism. Anything which is closer to the observer, like in this case face AD41, the yellow colored face is closer to the observer, so that face appears to be bigger in size as compared to something which is away from the observer, like face BC32. That face and all the edges on that face, they appear to be smaller in size. Now we can also make out one thing from this example, that is if this cube has this or this object has this edge AB longer in size, that is point or you can say face BC 32 is far away from the picture plane somehow. If this dimension is even more than 50 mm, then that will actually be pushing this face BC32 in the top view on this side. That will be moving these piercing points on the left, and if the piercing points move on left, then these vertical drop lines will also move to the left. That will lead to even smaller appearance of all these edges BC and B2 edges. These edges will appear even smaller in size. So that is the concept and logic of perspective views, that anything which is away from the observer, that appears to be smaller in size, so that gives it an element of realism. Thank you for watching this video. Now we will take up one more video on 2-point perspective.